Hello, my name is Hiba and I'm presenting an extension of PlusCal for modeling distributed algorithms. Let's start out by saying what is TLA+. TLA+ is a formal specification language. It is mainly used to model concurrent and distributed algorithms. The TLA+ toolbox is an IDE that provides many tools such as a model checker and an interactive proof assistant, for example. And since TLA Plus is more of a specification formalism rather than a programming language, it can be challenging for programmers to use it initially. So PlusCal is an algorithmic language that was created to accompany TLA Plus to give the users more of a familiar syntax while maintaining the same expressiveness as TLA Plus. However, if we are discussing distributed algorithms, we usually find ourselves needing to model interactive processes that interplay together in order to carry out a certain task. This need is not really met naturally in PlusCal, since PlusCal has more of a flat hierarchy when it comes to its processes, and it doesn't really allow a nesting of processes. So we propose an extension of PlusCal called Distributed PlusCal that enables the users to define subprocesses to model this parallelism, and as well as providing communication channel constructs that can help in the communication between these subprocesses. So we're going to start out by introducing a motivational example to highlight our contributions. We have chosen Lampart's Mutex algorithm. For those of you who are not aware, it's an algorithm for mutual exclusion in distributed systems, where processes request access to a critical section, and each request has a logical clock value, where the requests with the lower values have higher priority. So a process starts out by sending a request that it needs to access the critical section to all the other processes with a logical clock value, and then it waits for the acknowledgement from all the other processes to give it a right to enter the critical section. And once all the acknowledgements are received, it enters the critical section, executes its part, and then when it leaves the critical section, it notifies all the other processes that the critical section is now released. If we're going to model this algorithm in PlusCal, we're going to need two process types. The first process type will be just a process to carry out the main algorithm. So we can see here that we have a non-critical section, and then you have a try step where you multicast a message requesting the access to the critical section. And then in the following step, you wait for the acknowledgements from all the other processes. And once you get all your acknowledgements, you can move forward and enter the critical section. And eventually, when you exit, you again multicast a release message for all the processes, notifying them that the critical section is now released. We also need a helper process that can be responsible for the message handling here, or responsible for the communication between the processes. So the helper process here uses an operator that we have defined called node. Node here identifies the main process corresponding to the communicator C. And inside this block here, we are handling request, acknowledge, and release messages. So because we have two processes working together, the variables must be declared globally in order for them to be accessible by both processes. However, if we decide to model this algorithm in distributed PlusCal, it can be done in a simpler way. For example, we will have only one process type where you have two subprocesses working together to carry out this algorithm. So the first subprocess starts with this curly brace here and ends with this curly brace here. And the same thing for the second one, it starts here and ends here, where the first subprocess carries out the same logic that we have discussed before. You have a non-critical section and all the way to releasing the critical section. And the second subprocess handles the message reception, the asynchronous message reception. As for modeling channels for this specific algorithm, in PlusCal we declare a variable here, and we give it two dimensions where P can be the sender of a message, Q can be the receiver, and the messages are placed within a TLA plus sequence. In distributed PlusCal, however, you can simply declare a predefined type called FIFOs to represent a FIFO channel and give it the appropriate dimensions. Also, for implementing an operation in PlusCal, a channel operation, you will define a macro, give it the appropriate body, and then later on call the macro. Where in distributed PlusCal, you can simply use one of the predefined operators. For example, here we have an operator called multicast, where the first argument represents the channel name and the second argument represents an expression that specifies the intended recipients as well as the message that needs to be sent. Here we can see the general structure of a distributed PlusCal algorithm. It resembles the general structure of a PlusCal algorithm. The differences can be seen here, where you can define channels to represent unordered channels. You can define FIFOs like we have seen in our example. And here, instead of giving the process one body, you can actually give it multiple subprocesses. We have supported several operations on channels. For example, you can send a single element to a channel. You can receive. Receive is enabled when a non-empty channel receives a message into a variable, as can be seen here in the second argument. Broadcast and multicast send messages along several channels in an array, while clear empties the channel. If we take a look at unordered channels, we will see that they are declared using the keyword channel or channels. They are also based on TLA plus sets. So if a channel operation is actually invoked with an unordered channel, once it is translated to TLA plus, it will be using the TLA plus set operators, as we can see here and here as well. As for FIFO channels, they are declared using the keyword FIFO, as we have seen in our example, and they are based on TLA plus sequences because we want to maintain the order between the messages within the channel itself. And once an operator is translated into TLA plus, it will be using the TLA plus sequence operators such as append, head, and tail. As for the PC variable, it is a special variable in TLA plus, and in PlusCal, it represents a single string equal to the label of this next statement to be executed with respect to a process. We have extended this definition to include which subprocess is involved as well. Here we can see the initialization of the PC variable. So, for example, if we are handling a process of type P1, here we'll be giving a sequence where LBL11 represents the first label in the first subprocess, and LBL12 will represent the first label in the second subprocess, and so on. Here is a piece of translation that was produced by our own translator. This is the same exit atomic step that we have discussed before when a process exits the critical section and it releases a message for all the other processes, notifying them that the critical section is now released. The first thing to kind of pay attention to is the fact that the PC variable also references the number 1 here, which means that we are in the first subprocess. These lines represent the translation of a multicast operation when invoked with a FIFO channel. And we can see here even the PC prime variable also takes into consideration in which subprocess we are. So to conclude, we offer an extension of PlusCal called Distributed PlusCal. It gives the user the opportunity to define subprocesses that you would normally see coexisting within a distributed node. We also offer communication channel constructs that kind of assist in the communication between these subprocesses. We offer a backward compatible translator that translates from PlusCal to TLA+, as well as from distributed PlusCal to TLA+. And this is because we used the same translator that exists within the TLA+ toolbox before we extended the language. For future work, we intend to introduce more types of communication channels, and we are also considering defining a TLA+ standard module that the channel operations can get their definitions from. This can give the user much more flexibility to define their own operations as well as override the operations we have already introduced. Thank you so much for watching, and feel free to take a look at our GitHub repository and try out our translator. Thanks.